understanding, and then when you go back, try everything again. Okay. Everything. All right. So for these kind of questions, remember I told you before, if the angle is here, you want to draw the parallel line in this direction. Yeah. Similarly, it's here, so you want to draw in this direction. Right? Okay. Now note that these two lines are parallel already, which means when you draw two more lines, all four of them will be parallel. Okay. All right, let's draw the first line here. So this one is parallel, and then this one, it will be like that, right? And it's also parallel. Okay. Parallel, what does that mean? Look, this one is a right angle, right? Which means this will also be a right angle. Make sense? Yeah? Because if it's perpendicular, it's perpendicular to both parallel lines. Okay, that means that this angle here will be 90 degrees, and then this one would be 20 degrees. Okay, so when you get a question like this, note how I'm putting down the angle. So I put a line there, and then I put the angle next to that line. Okay. Now similarly, because these two lines are parallel, then that means this angle is 20 degrees, right? Okay. Why? Alternate angles. Okay. So these two alternate angles, which means this angle is how much?
150 minus 20, 85, 95.
95 degrees, yes. Okay. 95 degrees, now what's alpha then?
Alpha is 95 degrees.
Is also 95. Reason?
Alternate angles.
Alternate angles. Make sense?
Yeah.
Okay. That's why I thought you would be able to do that one. I thought that you would struggle with this one, more like. This one is a little bit harder. You need to see more angles of this one. Find the value of alpha. Okay. Where would you draw the parallel lines?
On top of alpha, like the line there.
Yes, the line at alpha, right? Like this line here, right?
Yeah.
Right, so it's parallel line. Where else?
At 30.
At 30?
No, 50.
At 50, yes. Which way? To the left or to the right?
To the left.
To the left, correct. To the left, like here. Okay, so what can we work out based on here? So let's see, let's try to look at alternate angles, right? So you see this one is an alternate angle. What's that value?
30 degrees.
30 degrees, that's right. Then what's this angle here?
20 degrees.
20 degrees, which means alternate angle, this one will be?
20 degrees.
That's right. So then this one will be?
That would be
alternate angle of this one.
20 degrees.
Yeah? You see? A bunch of alternate angles. So alpha is?
40 degrees.
40 degrees, that's right. Okay? So for most of these ones, as long as you draw a parallel line towards the side, the angle, to split the angles up, to the big angle up, you should be able to find a bunch of alternate angles or even corresponding angles. Alright? Let's see. The next one will be... Oh, okay, this one. Alright, we'll do question 3, and then maybe you can try question 2 by yourself. They're all similar. It's just find one angle in terms of the other angles. Okay. Alright, find x in terms of alpha, beta, and gamma. So once again, where would I draw the parallel lines?
Alpha, at alpha.
Alpha, yep. To the left, yeah. And then? There's one more angle. There's one more point where I would draw a parallel line.
X?
Yes, at x to split up the angles, right?
Yeah.
Okay, so what can we actually figure out here? So if this is beta, then what can we figure out? This
beta
angle is also
beta.
Beta. Then what's this angle?
The angle is
related to alpha and beta.
It's A minus beta. I mean,
yeah, alpha by minus beta, right?
Yeah.
Which means another alternate angle is this one. That's also alpha minus beta. Then how about this one?
That one,
hint, it's related to gamma.
Okay.
What kind of angles are these two?
Interior.
Co-interior.
Yeah.
Right? They're co-interior. Or what does that mean?
All in the same shape.
No, they point towards the same side, right? And so, because they're co-interior, what's the
They add to 180.
Yes, they are to 180, which means this angle related to gamma is how much?
is gamma minus x.
No.
No, gamma plus x.
No.
Gamma minus.
Remember, it's this angle, yeah? This one and gamma, yeah? Remember, they are co-interior, which means they add up to 180, which means this angle by itself is
90.
not 90. This one plus the gamma.
Is 180 minus gamma.
Yes, 180 minus gamma. So x is what?
X is 180 minus gamma.
Mm-hmm.
And gamma is...
No.
180 minus gamma.
That's not all. Remember, x, which angle is x? X is this whole thing, yeah?
Mm-hmm. So then...
It's made up of, remember, we drew the parallel line to split into this one and this one.
Okay.
Alright, so to get x, which is a combined angle, you need to add them together. Okay. Plus alpha minus beta. Does that make sense?
Yeah.
Yeah? Okay, because remember we split up x into this one and this one, right?
Yeah.
And then this one is the first angle, this one is the second angle, right? The first angle is this one, the second angle is this one. You just add them up, you get x.
Okay.
Okay, so that's the idea that when you have a bigger angle, and if you can split it using a parallel line, a line that's parallel to an existing line, you do that. Okay, and then you find all of the little angles based on whatever you can find, and then you might be able to join them together to get the bigger angle, which is x here.
Okay.
Okay. So this is an advanced one, all right. Okay. Let's try with this one. All right. Prove that alpha plus beta plus gamma is 180. That is the sum of the angles in any triangle is 180. How would we go about doing this?
Make like another triangle.
No, you don't. Hint, just use the parallel lines they already gave us.
Okay.
Hint 2, call this one. So you've got alpha, gamma, whatever, right? Let's call that angle x and this one call angle y.
Okay. Alpha plus beta equals x?
No. Again, parallel lines. The key angles of parallel lines are alternate angles and co-interior. Do you see an alternate angle or co-interior?
Yeah. Yes.
Yes. Which one? Alternate or co-interior? Yes and no. See alternate angles. Remember the Z rule? Alternate angles is part of the corners of the Z.
Okay.
Right? So you see two pairs of alternate angles in here?
Yes.
What are they?
Y and gamma.
Y equals gamma, alternate angle, right? And then?
And x equals alpha.
X equals alpha, very good. Alternate angles, okay? Mm-hmm. And then how do we prove that alpha plus beta plus gamma equals 180? So we note that. Do you have any sum of angles to be equals to 180? Like angles in a straight line?
Yeah.
Yeah, which one?
90 plus 90.
No, not 90 plus 90, based on this diagram here.
Oh, better. Alpha plus gamma.
Not quite. Angles on a straight line. So I'm talking...
X better than gamma.
Yes.
X better than y.
So note that given x plus beta plus y is equals to 180, right? Mm-hmm. Right, angles on straight line. Okay? Mm-hmm. Yeah. And we already proven that x equals alpha and y equals to gamma. Therefore, x is so alpha plus beta plus gamma is equals to 180. It's proven.
Okay.
Make sense?
Yeah.
Yeah. So the idea is that we're trying to, what I'm saying here is that we're substituting alpha into x and substituting gamma into y here. Okay. But first we need to prove that they are the same using alternate angles. Okay. Angles in a parallel lines, right?
Yeah.
Okay. Yeah, alright. So that's the general idea of this one. Let's see. Oh, I think you did these ones, right? Did you do question 7? Could you do question 7? Did you get that right?
I think it did, yeah.
Yeah, okay.
Yeah.
So you want me to go through this or not?
You can go through. Yeah, I can get through it, yeah.
Okay, let's go through it. How many minutes pass after 12 noon before the angle between the minute and hour hand is exactly 90 degree? So past 12 noon. So let's say at 12 noon the two, right, the minute, so the two hands are like that, right? So how many minutes past 12 noon there be so for them to be exactly 90 degree, at which point would they be exactly 90 degree? What do you think?
3 o'clock.
No, it's not 3 o'clock. It's not that obvious. It's a challenge question.
Oh, 12.
Imagine at 12:05, what does it look like? I'll say at 12:15, right? Let's say at 12:15, what does it look like? So
they're both in the same area. Okay. Yeah.
You see how this one will be a little bit off?
Yeah,
it's not center, right? Yeah. So when would they be? How many minutes past 12 would they be 90 degree? How do we work this out? Hence, you need to use algebra.
So I'm substitute the minutes for algebra. Substitute the time into algebra.
Yes, but so you have to form an equation. But how do you form an equation?
So isn't there another way you can do this? You do it just by testing it, though, right?
Well, no, you have to work it out. It's hard to test it out. It's very hard to test it. Okay, I'll show you the supposedly advanced one. This is the last question in the challenge question. Yeah, I'll show you how to work it out. So the easiest way is to use examples, and based on those examples, then you can form the equation. Okay. So for example, I think 12 is here, and then 12:15 is there. Right, so at 12:15, remember we did this question before, where what's the angle that the hour hand, so the hour hand and then the minute hand, right? So what's the angle of the minute hand? It's 90 degrees, right? So made with the vertical line.
Yeah.
What's the angle of the hour hand? We calculated that before.
The angle of the hour hand is 180.
This is not 180. I'm talking about the angle that it makes with the vertical.
It's.
Remember, if it points from, so initially it's 12, right? And then it points to 1, right?
5. 5.
How did you get 5? So first, from 12 o'clock to 1, what's the angle here?
Hold on, it's 5 minutes.
5 minutes, but what's the angle?
5 degrees.
How did you get 5?
60 divided by 12.
Not 60 divided by 12.
Is it 180?
It's 360, and how many gaps are there?
Oh, yeah, there's 12 gaps.
Yes, which is?
30.
30, yes. So the angle here will be 30 degrees, right?
Yeah.
But at 12:15, the hour hand only traveled
so it's a quarter of that.
Yes, a quarter of that, right? Times 1/4. So right now, the hour hand would be 30 times 1/4, which is 15 over 2. Okay?
Yeah.
All right?
So it's 7.5.
Yes, 7.5, but we'll use a fraction, and the reason, you see a reason in a second. So right now, the angle is 7.5, and this is 90 degrees, right? So note that so this is for 15 minutes. So use the thing called a unitary method. Okay? So they ask how many minutes would it make a 90 degree. So first, you find out how many degrees do they travel per minute. Does it make sense? So now we have 15 minutes, the hour hand and the minute hand, right? Hour hand is 15 over 2, and the minute hand is 90.
Okay.
So that's 15 minutes, right? So the unitary method says that, okay, you need to find how much they travel every 1 minute. Okay, so every one minute, how many degrees does the hour hand travel? How do you know?
Every 1 minute. It's 5. It's 30 divided by 5. Wait, 5 divided by.
So remember, you can use this one. So this is 15 minutes to 1 minute is what? Divide by 15, which means this value is also divided by 15.
Okay.
Right? It's just dividing 15 for each of these values. Does it make sense?
Yeah.
Yeah, because 15 minutes is 15 over 2. So divide this by 15. That would be how many degrees?
That would be 7.
How do you do 15 over 2 divide by 15? That's the same as times by.
Times 15 over 1. I mean 1. Yeah. It's 1.5.
Yes, it's a half. So that's 0.5 of a degree, or you use half of a degree per minute.
Okay.
So how many degrees does the minute hand travel every minute?
90 divided by 15.
Yep.
4.
Not quite. It's 6 degrees.
What?
6 times 10 is 60. 6 times 5 is 30. So 60 plus 30 is 90.
Oh, okay.
Yeah. So you can test it out, but just times it to the tens first, and then plus times that to the digits. Okay. So that's 60 plus 30, which is 90. Okay. So every minute it travels this much. Now, how do we know when they make 90 degrees to each other? It means that, let's just say the minute that we need is x minutes, right? And how do we form an equation? So remember, the angle made by the hour and the minute hand is 90 degrees to each other, right? So it's x minute times by 6, right? Minus, note that this is a lot smaller, right? So minus x minute times by a half is equals to 90 degrees.
Okay.
Does it make sense? Yeah. So the hour hand minus the minute hand equals 90 degree.
Oh, okay. Yeah.
Yeah. And this is the number, like the degrees of the hour hand and then degrees of the minute hand, right? The difference is 90 degree. And the sorry, that should be the minute. Minute minus hour, because minute travels faster, right? So the minute will be always have a bigger angle compared to the vertical line, and hours always have a smaller angle compared to vertical line. So know that this question is really advanced, yeah? So I'm introducing a new concept in unitary method. You're not supposed to learn this one until year 9, but knowing this will make this question a lot easier. That's why it's called a challenge question.
Okay.
Yeah. But anyway, it makes sense so far?
Yeah.
Now, so we're going to solve this. So that would be 6x minus x over 2 equals 90. All right, let's solve it. The first thing I would do is try to get rid of the divide by 2. How?
Put the x to the other side.
No, actually you will, okay. Maybe an easier way is to combine these two. So you see they're both x's, right? I'll write this as half x. 6 minus half is? 6x minus half x is?
It's 5 and 5.5 x.
Yes, 5.5 x equals to 90, right? And then
x equals 90. Is it divided by 5?
Divide by 5.5, right? Or divide by 5.5. Can you divide by a mixed number?
No.
No, so what do you do?
Improper fractions.
Yes, correct. So that'll be?
11 over 2.
Yes, how do you divide a fraction?
90 times 2 over 11.
2 over 11, right? Which is?
Like 16.
It's about 180 over 11.
Oh, okay.
Right?
I meant to do it like...
280 over 11. Yeah?
I'm not meant to solve it. I meant to solve it.
Yeah. I think just punch into a calculator and you get an answer. Just roughly, I think they asked how many minutes, right? So 180 minus divided by 11 is about 16.36. 16.36 minutes. So roughly that. Okay? Yeah. Alright, let me quickly double check to see if the answer they give is a full number, like a whole number, or a decimal number. But yeah, does that method make sense so far?
Yeah.
Okay. Now this one, this kind of question is not really something that I would expect you to see in the exam, but you can't be sure. They can give you whatever they want. Okay. Okay, and let's quickly see. So this question is 7, right? Chapter 6?
Mm-hmm.
Chapter 6. Okay, let's see. Oh, they give you they give it as a mixed number. So they give this one as 16 and 4 over 11 minutes. Yeah. Yeah, about 16 and 4 over 11 minutes. Okay. All right. So yeah, I think if you give as the decimal place, it should be okay too, or even just 180 over 11. But yeah, mixed number is the answer that they give you in the textbook. Okay. All right. Next. So that was chapter 6. The next one is chapter 14. All right. Okay, for chapter 14, is it the review question or the challenge question you want me to go through?
Challenge.
The challenge one, okay. Alright, let's have a look. Okay. Alright. Each row, column, and diagonal, okay. Find two fractions between... Have you learned simultaneous equations? I think I showed you, but you haven't learned at school, right? Mean question to give, but might as well learn it. Okay, complete the magic square on the right in which each row, column, diagonal must add to the same sum. The easiest way is to solve it using a simultaneous equation. So let's just say I have these two, x and y.
Okay.
Actually, let's see. You need another one. Oh. Row, column, and diagonal. Okay. Let me think. I'm thinking of what's the best option. Okay. Now, know that these ones, right, it's like Sudoku. The easiest one is to find the side where when you can form one equation, right? You can form one equation with the two equal sides. What I mean is this. If we choose these two, so they must add to the same sum, right? Then let's just, if I call this one x, and this one y, so let's say if I call this one x and that is y, then the first equation, so we're doing question 1, yeah, ignore the other two. So we've got -3 plus x plus -4, right, equals to something else.
Wait,
so that
how do you use Sudoku?
Huh?
How do you use Sudoku?
No, this one is, well, the idea is similar to Sudoku, but it's a little bit different. But anyway, ignore that statement. Basically, they're asking you to find the numbers where each row, column, and diagonal must add to the same sum.
Oh, okay. Yeah.
Okay? Yeah. So you have to choose the right square to start with. Now, if you choose this one, there's not really anything to work with, right? Because we know this one must add up to everything else, but then you can't really form another. So this one there's an unknown here as well.
Okay.
Does that make sense?
Yeah.
Yeah. That's why you would choose the one where you can form two sides of an equation. So that square there, we can start with that one first.
Okay.
I'll show you why. If you have this one here, right, we'll call that one x. Then you would have -3. So we go this diagonal first. -3 plus negative or minus 1 2/3 plus x is equals to -4. Hang on, -4 minus 1/3. Can't even solve this one. All right, let's see. -4 minus 1/3 plus x, and they must be the same. Wait, you can't actually solve this one. That's minus 4 2/3 plus x equals to minus 4 and 1/3 plus x. There's no number that you can make these two the same. Maybe, hang on, maybe what they meant is, let me double check, maybe what they meant is that each row add up to the same, and then each column will add up to the same, and then each diagonal add up to the same. Have you done one of these before?
No.
You haven't done any of these at school, right?
Mm-hmm.
I can show you how to do it, but you need to learn simultaneous equation.
We don't really do the reviews and stuff at school and all the challenges.
Sorry?
We didn't do like the reviews or challenges at school.
Oh, okay. So you've never seen the magic square question before?
No.
Okay, low chance they will give it to you. Right. I'm going to skip this one. I think it's safer to skip this one because if I have to teach you.
What we do is like at the end of learning a chapter, we do the review of it. But like that's only like once a
Okay,
yeah.
But you don't do the challenge questions.
No, yeah, I do the challenge questions, but like there's two different challenge questions. You can do the challenges, or you can do these like addition tasks the teachers makes. Like yeah.
Okay. Okay, my bet is they will not give you this question because if they haven't taught you the techniques to do these ones, they won't give you this question.
Actually, I think I've done a Sudoku thing, but like it's one made by the teacher.
Oh, like this one? Like similar to this magic square thing?
Yeah.
Okay, how did your teacher explain the steps to you? Did they go through that question?
No.
So they just give it the sheet to you. Okay, do this question.
Yeah.
Okay.
Like you have to pick what you want to do. You can pick review, challenge, or the addition task. The addition tasks are like really hard though.
Okay, I'll make a bet that they were not going to go through that one.
We can go through the additional tasks.
Which one?
Additional tasks.
Additional tasks?
Yeah.
Where are they?
They're not on the thing, but they're on my laptop.
Oh, they're on your laptop. Do you have any specific question from the additional tasks you want me to go through?
You can go through it and like see. They're a bit hard though to like.
Maybe email me the additional task for this chapter 14.
I can put it as like a PDF or something.
Yeah, let's have a look. Let me see what kind of additional tasks you were given. Because I think the hard question in the exam might be similar to your additional tasks.
Wait, which one is this? 13, right?
14.
14, okay. Yeah. So like, but it's for like each subtopic.
Let's see. Oh, is that the one where you just add up the?
This is 14B, and then like this is 14C.
Okay. Okay. All right. Are you okay with these ones?
Yeah.
Yeah, just add them up. Not too hard. Which one is for the 14D? Is it? How about the challenge exercise here?
It's the same.
Oh, it's just the same one.
But there is.
Did they even explain
the thing?
Oh, okay.
Wait, hold up. Oh, this one a year 9 textbook.
Oh, okay. So that's algebra 1.
Yeah.
Yeah, you wouldn't need to do this one yet. Wait, did they just change up one of the numbers? Oh yeah, as I thought, that one should be negative 2 and 3. I was like, if you use negative 1 and 3, you're not going to be able to do it. Yeah, okay. That's fine.
Okay.
Yeah, nah, I think let's skip this one. I'll go through the kind of questions that's more likely to come out in the exam, which will be... Okay, now for question 3, do you know how to do question 3? Arrange the numbers in decreasing order.
Yeah.
Yeah, so what's the largest in from part A? What's the largest?
It's... negative 3.63 recurring.
What's 7 over 11?
It's like a decimal.
Yeah, what decimal? You need to know what that is first before you can be sure. Okay, let's say you have a calculator, right? Let's say it's this one here.
So 4.2 recurring, right?
Mm-hmm.
Negative 3.60 recurring.
So is that one the smallest?
Biggest, isn't it?
Decreasing order. Okay, note that these are negative numbers, right? So if you were to put them on the number line, the easiest is to actually put them on the number line. So this is chapter 14. Okay, arrange in decreasing order, right? So for question A, the easiest is to use a number line. So note that these are all like negative something, which means I'll put 0 here.
Okay.
Okay. Now, if you were to test it, right, see how negative 1, so they want decreasing order, which means you go this way.
Okay.
Right, as you go to the left, it gets more negative, so it gets smaller. Right, so the one closest to 0 is the biggest one. Like negative 1 is bigger than negative 3.
Okay.
Right, which means when you're looking at the values in the negative, you need the smallest one.
Okay. Yeah, I got confused with the negative thing. Okay. So negative 3 and negative 3.042. And then it's negative 3.6. Wait, no. Yeah, negative 3.6.
3.6 recurring?
Yeah.
So that's negative 3.6666, yeah?
Oh, no, negative 3.63.
Yes.
And then negative 3.63 recurring.
Yep.
And then negative 3.6 recurring.
Yeah, that's right. Okay, so watch out. If it's negative, you are looking at the decreasing order, so you want the largest first, which is the smallest negative number.
Yeah.
Alright? Yeah, so it's a little bit tricky.
Actually, for instead of doing this, I have more test-like questions. Like diagnostic tests. Yeah.
Let's see.
Like I did one today, and so this
yeah. How about, we do these ones.
Okay.
Oh, very, very similar. Okay. Yeah, maybe email me this one if you can.
Okay.
It's this one, right? Just email me the PDF one. Can you download the PDF?
Yeah.
Yeah, email me the PDF. I'll go through those ones. So 14, 17, and 16.
You want me to jump 13?
Yeah. 13 as well. 13, 14, 16, 17. Yeah, email them to me.
15, 16. We did 17 today. I got 11 out of 12. I made a silly mistake here by accident.
Okay. Then maybe I will go through the challenge question for 17 then.
What about 18? I can send 18. That was a bit harder.
Okay, yeah. Email me the ones that are harder from your diagnostic test. And when we finish all of those, if we have time, then I'll go through the challenge questions for these chapters.
You would do percentage and ratios as well?
Do you want me to go through them? Then say no.
Okay, yeah.
Yeah, it depends on which topics you feel like you want to get more explanations on. very easy to see these. Okay, we'll start from chapter 13 then. Angles. Diagnostic test. Okay, alright. Question 1. Easy, medium, hard?
Easy.
Okay, question 2. Easy, medium, hard?
Easy.
Easy, what's the answer?
120.
Okay, what's the rule?
It's the the internal angle, external?
Exterior angle
External,
theorem. Yeah, that's right. Okay, question 3. Easy, hard? Easy, medium, hard? Okay, I'll quickly go through
I
this.
think it's
We'll figure it out under 5 seconds. It's either medium or hard. So first, you figure out this one to be 45 degrees. Now, remember, isosceles triangle has two things, right? So the angles are equal, the base angles are equal, and then the two sides are equal.
okay.
Right? Now, we don't have any sides here, so the only thing we can rely on are the angles, right? So if this is 45 degrees, because it's complementary angle to 135, what's the other angle then?
45.
Yeah, 45 degrees. The two base angles are the same. So then it's an isosceles triangle, and then these two sides are the same.
Okay.
Okay?
Yeah.
You know how to write it out?
Yeah.
Okay, alright. Now, alpha and beta for question 4. I think this one will be a little bit trickier. What's the answer for beta?
What is better?
This one.
What's for
Okay, what's the theory? Again, two parallel lines. Is it an alternate angle or co-interior?
Co-interior?
Co-interior. So, what about co-interior angles?
Beta 180.
Yep. So, what's beta?
Beta is. Wait, the angle that RQP?
RQP is this one.
Yeah.
No. I'm talking about co-interior. So, it's this and that.
Yeah.
Right?
95.
95, yes. You see it now? Co-interior angles?
Yeah.
Okay, that's what's alpha.
Alpha is 95.
No.
Wait,
Remember, parallel lines, either co-interior or alternate.
okay.
If you can't see a co-interior,
45.
yes, find an alternate angle. Okay?
Yeah.
So it's either alternate angle or co-interior. Alternate angle, you can use the Z rule. It's just two corners of the Z.
Okay.
Okay, look for a Z shape. Okay, so that's alternate angles. Alright, this one. Is that all? Oh yeah, it's just these 5 questions. Find the value of alpha and beta where O is the center of the circle. So how do you find alpha and beta?
So 35 alpha, and alpha is so it's isosceles triangle, the triangle AOB.
Yep, okay.
So 35 angle OAB is 35 degrees.
Yep. OAB is 35, yes.
And ABO is also 35 degrees.
Yes, correct.
So alpha is 20 degrees.
No.
Wait, no.
That's really small. That's an obtuse angle.
Okay.
It's more than 90.
Wait, it's it's 120. I know 120.
No. What's 35 plus 35?
110.
Yes, 110. Can't make these mistakes, yeah?
Yeah.
110 degrees. Okay, how do we find beta?
Beta is just
Okay, first, actually, before that, these two sides are the same y. AO.
isosceles triangle.
Yeah, why they're the same? Because they are?
The base triangle. Base.
No.
The angles in a straight line.
No.
Out of 20.
AO and OB, they are equal to each other. Therefore, AOB is an isosceles triangle. But why is AO equals to OB? What's the reason? radius of a circle. Right? If I draw any line from O to the edge, it's all the same. They're all radius of a circle. They're all the same.
Oh, okay.
Okay? So when you see a circle and then one of the point is a center, watch out for radius of the circle. Okay. Right? And A and OB are equal because they're radius of a circle.
Okay.
Like that. Okay? Radius of circle. And because these two are the same, that's why AOB is an isosceles triangle.
Okay.
Okay? If you don't say AO equals to OB, radius of the circle, you won't be able to get the mark for triangle AOB is an isosceles triangle.
Okay.
Because you're just playing it by ear. You're not actually giving a reason. Okay? And so how would we find beta?
Beta,
Do you see another isosceles triangle in there?
Yeah.
Yeah, which one?
One right there.
What's the name of that triangle?
OBC.
OBC, yes. And which two sides are equal?
OBC, OC.
OBOC equals y.
The radius of the circle.
Yes, radius of a circle. That's right. And therefore, a triangle OBC is isosceles, right?
Yeah.
Okay, and then?
And then, so
what can we do with an isosceles triangle?
they add up to 180.
No, all triangles are like that. But for an isosceles triangle, what is special?
The
two sides are the same and?
One is the apex.
No, the two base angles are the same.
Yeah.
Yeah? You didn't get this, okay?
Wait,
so remember, isosceles triangle, two sides are the same, two base angles are the same. Okay?
It's how different the other one then. The other one.
The other one is also beta. And now how do we find beta? Can we find something else? Can we find this one?
Yes.
Yes, what's that angle? It's 70 degrees, exterior angle of a triangle. How do we find beta?
It's 180 minus 70. 2 beta equals 180 minus 70.
Yes, 2 beta equals 180 minus 70.
And then 2 beta equals 110. Yeah, so beta equals 110 over 2.
Which is?
That's 65 degrees. I mean 55 degrees.
Yeah, 55 degrees. Okay? Make sense? Yeah. So remember, isosceles triangle, when you see isosceles, right, you need to think of the special properties of isosceles. So equal sides and equals base angle.
Okay.
Okay? You have to think of these two concepts. Isosceles, equal sides, and equal base angles.
Okay.
Right? If they are asking you to find sides, then you use this. If they ask you to find the angles, then you use this.
Okay.
Right? And vice versa, if you want to prove that the triangle is isosceles, either you can find equal sides and say, oh, therefore it's isosceles. Or you can find equal base angles and then say, oh, therefore it's isosceles. Similar to this one, right? Equal sides, therefore isosceles. Right? And then the question before was equal angles, therefore isosceles.
Okay.
Yeah, so it would be something like angle CAB is equal to angle CBA, right? Yeah, angle, right? Therefore, ABC is isosceles triangle. Oh, there's another S here, isosceles. Okay, make sense?
Yeah.
Yeah? Yeah, so therefore, triangle ABC is isosceles. Okay, so note that the isosceles triangle, you need two things: equal sides, equal base. Alright, to prove isosceles, equal sides, prove isosceles.
Okay.
Or equal base angles, prove isosceles.
Is that it?
Yeah, that's it. That's all you need to remember for isosceles triangle.
Questions?
Yes, that's also it for the questions.
So can you go to the other one that I sent you? Next one that I sent you. I was gonna see if I know what I'm doing for that one, because I just sent like the topics that I will ask you before in Discord.
Was it
No, I don't. No, it's not that. I don't know why I sent you that.
Was it these ones? But these are from the other chapters, though. That's 14.
Yeah.
Okay, you want to go through this one? Chapter 15.
Wait, let me just see my marks for those. So chapter 15. Wait, chapter. I got 10 out of 14.
Which question did you make a mistake in?
2 and 3B.
Okay. Okay. 2 and 3B. So you got 5?
Yeah, I got 5 correct.
Okay, alright. Let's go through 2. Each quantity as a percentage of the second. So this one as a percentage of that means what? It's 5 on top. So what fraction it is, but then you need to times it by the 100% to get percentage. Okay. Did you miss the times 100%?
Yes.
Yeah, that was the main reason, right? Then you've got 500 over 12, right? Percent, which is, then you can simplify that first. So 250 over 6. Simplify one more time. 125 over 3. Right, and then divide it. That will be 41 and remainder 2 over 3%.
Okay. Yeah.
Okay? Make sense?
Yeah.
All right. And then this one, 14 cents and $10. So once again, you need to convert them to the same units. So I would convert it to 14 over 1,000.
Okay.
Yeah, because if you use 0.14 over 10, you still need to times it by 100 to make it into whole numbers.
Okay.
Right? So I change them all to cents. So that's 14 over 1,000 cents.
Okay.
And then you want to convert to percentage, right? So times by 100%. So the main thing you need to remember here is the times by 100%.
Okay.
Okay? Yeah?
Yeah.
Then you've got 1,400 over 1,000. Again, chop off the two zeros. That's 14 over 10, which is 7. Or actually, you can go 1.4%.
Okay.
Okay? Make sense? All right. Next would be question 3B. So when you see off, right?
Times.
It's times. That's right. So
at least check the mistake for it.
yeah. So not 220%, you gotta convert it to a fraction form. So it's 220 over 100.
Okay.
Yeah, and then times by $50. Yeah. First, chop off the zeros. Second, simplify 5.
Wait, I don't know how I got it wrong. I think I just made a silly mistake on it.
Did you?
Is it $205?
No.
Wait, hold up. So 100% of $50 is $50, and then 200 is $100. 20% of 50 is $250. Wait, no. 20% of 50.
Find 10% times by 2. What's 10% of 50?
10% of 50 is 10.
No.
Wait, no, 5.
Yeah, times by 2.
10.
Yeah.
110.
Yes,
I
110.
got 105.
I think you could calculate the 20% wrong.
Okay, yeah. Yeah, I did.
Or you can do it this way. So do 210 over 100 times by 50.
Okay.
Right? Now, the method that you did was for more like mental calculation, right? So it's for estimation in real life.
Yeah.
But in math, you want accurate. So you would use a more accurate method.
Okay.
Yeah, like 220 over 100 and simplify 50 and 100. That would be 1 and this one would be 2, which is 220 over 2, which is $110.
Okay.
Okay, so in when you're working out in the exam, I think keep the mental math to the questions that are simple enough. But for these ones, don't use mental math for them in the exam.
Yeah, okay.
Because they want to see the workings for these questions. All right.
So let me do the wait, which one? What else did I send to you?
I think you sent me 14. Should be this one here. Yeah, 14. Okay, how did you go on these ones?
Wait, hold on. This one's not marked for some reason. I think I was like away or something when we did it or something. I'm not sure, but
Out of 16, I think
It's just
the
empty.
ones that you would potentially struggle with would be question 6, maybe. Yeah, question 6. Or 5B. You know how to do 5B?
yeah, okay.
Yeah? Let's try 5B. So write it as a fraction. Right? 2 negatives cancel each other out, and then I want to times this by 10 to get rid of the decimal. Right? So that would be 1, 2, 3 on 3. Yeah? And then want a decimal.
Okay.
Right? Well, this one is easy. It's just 41.
Okay.
Yeah? Okay. Yeah, that's it. Now, question 6 is a little bit tricky. That's a 6b. So that's 2 times. Make sure you put it in the brackets, yeah? Negative 0.3 squared. A negative number, when you square it, you get a positive number. So that's the same as 2 times 0.3 squared.
Okay.
Like that. Okay? What's 0.3 squared?
Is 0.9.
Wrong.
No.
Number is 3 times 3, and then you add the decimal.
0.27.
No, it's 3 times 3, which is 9. And then you add back the decimals.
3. Wait, what do you mean?
When you're doing it, it's essentially just do 3 times 3, which is 9, and add back the decimals. How many decimals? 2. 1, 2.
Oh, and then do it again?
0.09?
Yeah.
But you want to see that again? Or?
Oh, I know, it's the power of 2. Oh, I thought it was the power of 3. Okay.
No, power 2. Squared, yeah? Squared.
Okay.
So 0.09.
Okay.
And 2 times that is?
0.0027.
No.
0.027, isn't it? 0.027?
No, it's 2 times 0.
2 point...
Easier than you think. When you are multiplying decimal numbers, it's essentially, so let's say 0.09 times by 2, right? When you multiply, you essentially ignore all of the zeros and the decimals and whatever, and just do 2 times 9, 18, add back the decimal. How many? 2.
Okay, 0.18.
Yeah, or you can think of it as 0.09 plus 0.09, which is 0.18.
Okay.
Right, because 2 times of that, so it's 0.18.
Okay.
Okay? So, yeah, I think your decimal number multiplication is a little bit rusty.
Okay.
Should go back and practice that.
Okay.
Oh. Now, 3x, everything squared.
Could,
3 times, note that this is negative 1/2, everything squared, right? Which is negative 3 on 2, everything squared. What's the answer?
Negative.
Would the answer be negative or positive?
A positive.
Yes.
Yeah. 9,
Positive?
9 over 4.
Yeah, it's just positive 9 over 4. Can't simplify it, that's it.
Okay.
Okay?
You can simplify it.
No, you can't.
Why?
Unless you say you want to convert to mixed number, then yes, you can convert to a mixed number, but you can't simplify the fraction any further. Yeah, because they don't have any more common factors.
Yeah.
Yeah, because the top, because you square it, so the top is 3 by 3, bottom is 2 by 2, there's no common factor.
Mm-hmm.
Alright. Okay, so that's that, and okay, your fraction's okay. Now note the ascending order. What's the lowest one?
The negative 1 and 1 over 4.
Yeah, that's the lowest one, and then?
Negative 1 over 4.
Yeah, that's right, and then 3 over 2. Yeah, I think the only thing that you need to work with is the decimal number, division and multiplication.
Okay.
Maybe you can find them, I think, in the challenge question as well for chapter 14.
Like the addition.
Maybe. Let me see. Oh, okay.
So what is it for? Is dividing? What is it dividing again? Dividing.
Decimal. Divide by a decimal number. You know how to divide by a decimal number?
I can't find any here, but
It's like these ones. These review questions. Evaluate you giving your answers in decimal forms.
It's for part 14.
Chapter 14, yeah.
It's your part D.
No, review. These are review exercises.
No, okay.
Yeah, question 4.
Okay. No, it's 14D. They're
14D?
from 14D. Like question 5 or like 4 or something.
Like these ones? That's 14D, yeah?
Yeah. Like this one here, E for 4E. It's like the thing I just did.
Yeah, but I think those ones should be okay.
Okay.
Should be okay for you. Okay, if you want to practice question from 3, 4, and 5 from 14D.
Okay.
Yeah, 3, 4, and 5. So yeah, if you want to practice, it's these ones here.
Okay.
Okay. Yeah, the notes in the recording, so you can check that later. So yeah, so that's what you should practice from 14D. I've shown you some examples, so...
Okay. Which one next? Oh, diagnostic.
Okay, let's do another diagnostic. The last one. The last one is, I think, 17. Or did you send 18? I think 18 was one you sent me. Yeah, 18. Okay, which question?
18. Wait, hold up. I don't think I did too well on this. Yeah, I got like an 8 out of 12.
Okay, which question?
Okay,
question 1, you okay?
I said translated 2 units to the right and then translated 1 unit down.
That's wrong. 3 units to the right.
Okay.
Yeah.
No. The second bit was correct.
The
second bit was correct. Translated 1 unit down.
Yeah. Now, the trick to do these ones is you find a point. So when you see transform, right? Just find a point and see and mark the new point and see how you get to the new point.
I don't know, I think you just counted wrong or something.
Yeah, probably. Yeah, but that's what I'm saying. Put the points in there and then draw the arrow. Look, if you put the point in there and then draw the arrow, there's a lower chance that you get it wrong, right? So to draw the arrow to the side, arrow down.
Okay.
So draw into the shape. Okay, it will give you less error.
Okay. And then also 4.
Question 4.
Yeah, the reflection symmetry was correct, but the rotation was wrong. Is it like 1 for rotation symmetry?
Rotation symmetry, yeah, 1. Yeah.
And then 6.
2 successive transformation that will have the combined effect of mapping that to the other one. 2 successive transformation. All right. So the first one will be a translation, right?
Mm-hmm.
Yeah.
Yeah.
So
well, I did 2 units up and then translate 6 units left. 2 units up and then 6 to the left.
Yeah, that's right. Okay, you should have gotten the map for that. And then what's the second transformation?
That's 1 translation. What do you mean?
Yeah. Okay. So the translation, the statement for the translation is considered 1 transformation. Yeah. That's not 2 steps. That's 1 step.
So what do I do afterwards?
Because when you do that, that's not the end. So note that when you translate it, right, the top is B and C, but look, the top is F and E.
Oh.
That was a mistake. You missed 1 translation, 1 transformation.
Let me just check it, like for the actual answers.
Yeah, you have to reflect in the line AD.
Okay. Yeah. Wait, this one.
Right, B becomes F and C becomes E, which means it flips the shape around the line, reflects in the line AD. Yeah, so either you reflect that first and then you translate, or you translate it first and then you have to say reflect in the line AD. Okay, so that's what I'm saying. For these transformation, right, you need to highlight the point, but for these one, a little bit tricky, you need 2 points to make sure the 2 points will transform correctly. So for example, right, I would highlight point A and see, okay, so move there, yep, that's fine, but where's point B? So point B is top and then suddenly it becomes at the bottom. Okay?
Mm-hmm.
Yeah.
So yeah, reflect, right?
Reflect in the line AD, yes. Okay? So that's what I'm saying. You need to mark into the question. Circle the points. For this transformation, you need to recognize where the points go. So circle, just focus on the point A, where does it go? And circle point B, where does it go? And you realize, hang on, B from here, it turns to the bottom. How do you do that? Reflection. Okay. Yeah, I think you just missed the transformation, that's all. All right. What else? Right, so that should be 1 mark and the other one 1 mark here and 1 mark there, 3 marks. I think you lost 1 more mark somewhere else.
Did I? Wait, hold up.
Because you got 8 out of 12, right?
No, the bottom one had 2 marks. So I lost 1 mark for question 1. And then I lost one mark for question 4, and then 2 marks for question 6.
Oh, okay.
Because like it's out of marks, it's not out of like one question.
Oh yeah, you have to mark in and refer to any mirror lines or center of rotation.
I think I should have got the first bit right.
Yeah, but they think they didn't give you the mark because 1 mark is the 2 transformation. That's 1 mark,
yeah, no,
right?
It's put into 2 marks.
Yeah. I think the mirror mark in and refer to any mirror lines or center of rotation. I think that's the 1 mark, maybe? I'm not sure.
Yeah,
maybe they missed on 1 mark because you said the translation, right?
Yeah.
Up by 2, left by 6.
Probably they had a different translation, so like I just marked it.
What did it say?
It said like flip first or something, and then like it's like flip and then move it down or something. I don't know.
No, you flip it, you still move it up by 2 and left by 6. Right? Wasn't that the answer? Let's see.
They have no answer. I just want to check.
Oh, okay. That's strange. I think that's because they might have required you to do both of them to get the 2 marks or something. Yeah. Anyway, now you know what the transformations are. Okay, so the translation is considered one transformation.
Okay.
Yeah, it's just like boom, boom, and then that's done. And then the other transformation is either reflection or rotation.
Okay.
Okay?
Mm-hmm.
Yeah, there's 2 types of transformation. Okay. Alright, rotation is okay. Oh no, that's reflecting. Yeah, that should be alright. So you got full marks for question 5?
Mm-hmm.
Okay. Yeah, then that's fine. Yeah, I think that's all from your mastery test.
Can I send you another one?
Let's see.
Sent you 15, 14.
Yeah, we went through 15, 14, 13, and 18.
Did we go through 13?
No, 6, right? You said
we
6,
did.
not
Oh no,
13.
we did go through it. We did. What other chapters do you want to go?
Didn't you ask me to go through chapter 18 for you?
Yeah, we just did.
7. Was that 18?
Yeah.
Oh, right. 18. Last one is 19, right?
No, 17. Probability.
Wait. Let's see. You asked me to. Okay, let me double check the thing. You asked me to go through 16. You have 16?
No.
There's no.
I did ask you about 16.
Yeah. You mentioned 16 as well.
There was no diagnostic. Wait, let me just double check.
Yeah, send me the diagnostic for 16. Yeah, we've gone through 13, 14, 15, and 18. Yeah.
16.
Or I can just use the textbook. Is fine.
No, I did. I just didn't send it to you. I didn't.
Okay, yeah, send that to me. That's a solving equations one. I think this challenge exercise is actually pretty good to go through. It will be, I think, might be similar to your diagnostic test. Okay, we send it through.
Mm-hmm.
All right, got it. Okay, what was your mark for this one?
My math was... No, I didn't do that one. I was like, I think all the way or something because I can't find it.
Okay. You should be able to get most of these, except for... I think the hardest one for you should be question 6 here. Alright. Perimeter is 400, find the value of x. What would you do? Question 6.
Just put put them on the other side as well, like x minus 30 and 2x plus 20.
Okay, and then?
Try add it together and substitute.
What do you substitute?
The x or something, I don't know. Like, put the x's on one side.
Let's see. So you were saying this, right? Like that, right?
Mm-hmm.
Okay, and then?
2x plus, 4x plus 40
Mm-hmm.
plus 2x minus 60 equals, and then oh wait, put a new line.
You need equals or something here.
Okay,
what else have you not used? Give you an equation to solve x.
40 and 60.
No. What? There's something else in the question, very important that you
400.
use. Yes, equals to 400. Okay. So normally in the equation you need to form the left and the right hand side, and then you can solve for x. Alright. Now an easier way to solve this one is this. Look, perimeter is all four sides, right? But look, a rectangle, if you chop it in half diagonally, half the perimeter is just the width plus the length.
Okay. Wait, just checking the other diagonals.
Okay.
Okay, yeah.
The other one's okay?
Yeah, yeah. No,
Okay.
about the 18, I got it correct for one bit. Yeah.
Okay. Alright, let's continue on this chapter, chapter 16. Is this the last diagnostic test you want me to go through?
Yeah.
Alright. And after that we'll do more questions from the challenge exercise of chapter, I think 16. Now, this one, perimeter equals to 400, means half the perimeter equals to what? So this side plus this side equals to 200.
Okay.
Right? Which means I don't need to add the other two sides. I just go x minus 30 plus 2x plus 20 equals to 200.
Okay.
And then you solve it. Right? So first combine the x term and then combine the constant terms. So that will be 3x minus 10 equals 200.
Okay.
Right? And then move this term to the other side. 3x equals to, that will be plus 10, it will be 210. And so x would be 70.
Okay.
Okay, so the value of x is 70. Done. Box it up.
Why is it 200?
Because it's half of the perimeter. So note that this is the width, length, right? So when you add up to get the perimeter of
only adding half.
Yes, you're only adding half of it. Yeah? So we're chopping it in half and we only care about these two sides here.
Okay.
That's half of the perimeter. So add up to 200 instead of 400.
Okay.
Right? So some question you can do, if you can simplify it, it will make things a little bit shorter. The number's smaller as well. Okay, these ones are easy ones. I actually want to go through this one. Let me show you. Chapter 16. Challenge. These kinds. Now question 1 here. This is a very reasonable exam question. Why? It's doable within a time limit, but it's hard enough that if you don't know how to do it, you can't even start it. Find the perimeter of the figure below in terms of x, right? All angles are right angles. So, how would you find the perimeter in terms of x? See, this one is about shifting lines. So you see, if I shift this line, because perimeter, right? I shift it up. If I shift this line up, whoops. See if I can. Got another question first?
Oh no, never mind.
Okay. All right. Now, if I shift, see this line? If I shift it up, it's still the same perimeter, right? But now I sort of ignore this one here and I focus on that one there. Similarly, if I take this line and then I shift that. Oh, whoops. Keep on doing this. Okay, if I take this line and I shift that to the left, then I would get the line over here. Make sense?
Yes.
So what's the perimeter? It's just this whole line plus that whole line plus that whole thing plus that whole thing.
Do that with any perimeter?
Almost all of them, as long as the angles are right angles. Because if you have a shape that looks like this, then you can't do that.
Okay.
Right? Only when is the say that line there and this line there, then you can move this line over here and move that line up here.
And this is what chapter is this again?
16. Algebra.
Oh, okay. We had one today for a warm-up, but it was from a student. They asked if they could make their own warm-up. But it was a perimeter, but it wasn't algebra.
Okay. Well, this one you need to solve algebra. So most likely, if it comes out, it will be like this kind for the harder questions. So yeah, so this is the one where you need to form your own perimeter, and they say perimeter is 64. So you would do 2x plus 2x plus 3x plus 3x equals 64. Or recognizing that you can chop it in half, and you do half the perimeter, which is 2x plus 3x equals to half of 64.
Okay.
Yeah, which is 32. Right? And then you've got 5x is equals to 32, so x would be 32.
It's the same as the one before, right?
It's the same as the one before, once you've got to this point.
Okay.
Okay? So this is a reasonable exam question, similar to the one that you had, but it looks a little bit different. Okay. Any other question you want me to go through? Otherwise, I'll just pick random hard questions. Yeah, okay. Which one?
Isn't this thing the other day?
That's Criterion B.
Yeah.
Is this part of the exam?
The verifying bit I think is part of like. Well, no, it's not part of this. The probability is part of it, so it's probably going to be part of it then. So they would not give it to us.
Okay, that's chapter 19, right?
Yeah. No, it's not. Wait, is it? I don't know if it's in there. I'll just like I can print it and send it to you.
Now, let me see if I can find something.
I don't think it's in there.
Oh, it's not in there. That's not 19. That's probability. Probability is
It's 19. 17.
17. Yeah, send that to me. In the meantime, let me just search for. Okay, have you emailed it? Okay, I see. Oh, the quality is a bit low. Let's see. Practice investigating patterns, relationship between number of tosses. No, I don't think this one will be part of the exam.
Okay.
I don't think so. Yeah.
If you want to just go through these and these things, and you can like find anything. Yeah, it's like starting from like weeks, maybe like 5 or something. Yeah, week 5.
You should be okay with this one. This is the similar to what you've already done for the other one.
No, it's not starting. It's talking about week 6 then.
Oh yeah, these are the review questions.
Yeah.
Should be alright. Negative fractions and decimal. Oh, that's just the answers. Okay. I think your 15, chapter 14 should be okay. Go back and try, if you are in doubt, just try the review questions again. Just try, look at the harder ones and try a few of them. See if you get it correct. If so, that should be okay. And I think we've gone through all of these already. You know how to do these ones? The one where you expand the brackets?
It's like, is it times 2 times 2x and 2 times 1?
Yeah.
Okay.
Yeah, and then just move the constant term to one side and solve for x. Yeah, so it should be okay. I think the hardest one for you is still the angles in the triangle.
Wait, so like there's still try like the ones without the things that say review, like that, something like that.
Not that one. Can you do these two questions? Do you know how to do these two questions? These are definitely the harder ones.
Wait, let me check if I did it. No, I didn't.
Didn't do that? Okay. Quickly take a screenshot, send me on Discord. I'll just quickly go through that question for you.
The entire page is just... Just the entire page is just that?
No, it's just a question, it's fine.
Including the working or?
No need of working.
The teacher's working, okay.
Yeah. Okay, let's see. Yeah, these are... oh yeah, just send me on Discord. It'll be faster. Are you trying to erase some...
No, I'm just getting rid of the answers.
Oh yeah. Okay, cool. Okay, alright. This one, in a town of 1,000 household, 1/10 own 2 cars, and they ask you to find a fraction of household with no car, giving the answer in the lowest term. Okay, so it's basically this one plus the rest who do all own a car add up to 1. Right? So for question A, it's just this one, because when you add up all of the fractions, they must add up to 1. Let's say that's x, right? Like that. Right? And simply just 1 minus the sum of the other two. So I'll just quickly fix that up. That'll be 6 over 10, and that will be 7 over 10 if you add them together. And so x would be 1 minus 7 over 10, which is 3 over 10. Right? So that's the fraction.
That one, just not the B and C.
Not the B and C, right? Okay, so far we've got 3 over 10. Now let's try B and C. X represents the number of households with 2 cars, Y with 1 car, and Z with no car. The values of X, Y, and Z is essentially just the number, right? So if you try and find X, Y, and Z, they're actually asking the number, not the fraction. And this is the fraction of how much? 1,000. So essentially, X would be fraction on 2 cars, so that's 1,000 times by 1 over 10.
Okay.
And the other one's the same, right? And that would just be 100. Then Y would be number of household with 1 car, so that's just 3/5. Once again, it's a fraction of 1,000, right? And we did that 6 over 10, which is just be 600. All right? And the fraction with no car is 3 over 10, so Z would just be 300.
Okay.
Like that. Okay? Now, X to Y to Z in lower sum. Okay? This one may be the hardest one. Ratio. So you've got 100 to Y, which is 600 to 300. What's the lowest term?
100. So 1?
Yep, so 1, 2.
And 6? 3.
Yeah, that's it. Easy. Okay, so these questions are actually not too hard. They're not as hard as some of the challenge questions I've seen. Yeah, this one's
What
actually
chapter
okay.
is this? What? I don't know what chapter this is from.
Find the perimeter. 5, 6, 4. What chapter would that one be? Let me see. Not that one. Construction or visual equation probability. I think okay. That one is similar to the one from chapter 14. I think that question there is just a revision for, remember the one we did where there's perimeter? Yeah, for chapter 14.
Yeah.
Yeah, I think it's just a review so that you can do that question in chapter 14 where you need to calculate perimeter of shapes using X and using algebra.
Okay.
Yeah. So I think that's just related to chapter 14. That's about it. How about this one? Yeah, it's just percentage and ratios.
Yeah.
Okay. So out of these chapters, right, which one do you think you have the least confidence in?
13.
13 is the least confidence.
Yeah.
Yeah, triangles and construction, right?
Yeah, hold on. Let me just find it. Yeah.
So that's, I think 6, 7, 11, and 12, we've gone through all of them.
This is 13. So wait, hold on. Let me just find.
13 would be your weakest one, I think.
Said from one of them.
Wait, on Tuesday? Wasn't Tuesday one of those?
I'm just trying to find it says here something. It's not here. Yeah, never mind. No.
You're getting a little bit...
Not mine.
Yep.
Yeah, this is mine actually. Not my hand.
Okay, that's fine. No, 3, 6. Okay, I'll just go through a few questions from chapter 13. 3, 6, 7. Like these questions from chapter 13. I think it's these kinds of questions that would trip you up quite a bit.
Great. So like anything from here then from like 13. It doesn't start from there, it starts from like angles. But what's triangles and so? I didn't do this in school. But this seems like a Criterion A sort of thing.
Draw 3 different triangles, go through the center point with 2 points on the edge. Can you work out the angles in your triangles? Show how you calculated the angles. Okay, yeah, I think this one is we can go through this one. I think we have just enough to go through one more, just enough time for one more question. Which one you want to go through? This one?
Yeah.
Yeah, okay, email me this one. Just the triangle, just the circle. I just send that circle to me on Discord is good enough. I'll go through the questions looking at that circle. Okay, alright, let's have a look. Oh, it's a bit hard to see.
Okay, I'll just send.
Yeah, just send me the circle. And then I'll look at the question from your book. Okay, alright. Let's say this one, right? Okay, alright, let's have a look. Okay, so yeah, keep the questions up. So this one, right, how many different triangles? The easiest is just to draw out some example. When you join two next to each other, you get the first one, and then when you join two that's a little bit further away, you get the next one, right? And then that will be 3, and this one will be 4.
Okay.
Right? If you draw another one here, it's the same triangle as the previous one. So essentially it's just 4.
Okay.
Alright, now 3 different triangles that go to the center point with 2 points on the edge. Can you work out the angles? Show how you calculate it. So for example, see this is the first one where the 2 points are next to each other. The next one is when they are 1 point apart, which is like that one there, right? And the next one could be 2 points apart, so 1, 2, and that would be the last types of triangle. Okay, so let's focus on the smallest one first. Now, how many points are there? So if we do this one here, how many of those triangles? 1, 2, 3, 4, 5, 6, 7, 8. Right? Which means this angle here is 360 over 8. Make sense?
Yeah.
Yeah, because you make 8 of these, right?
Yeah.
Yeah. Now that's 360 over 8. Now the next one would be, and once you've got this one, note that these are all radius. Remember, triangles in the circle, all radiuses, so they're all the same. So if you got 360 over 8, then 180 minus that, divided by 2 is these two.
Okay.
Alright, so the base angles are all the same. It's just 180 minus the angle over here, and then divide by 2.
Okay.
Alright, now the next one, once again, is the same thing where you find out how many of these triangles are there. So 1, 2, 3, 4. Now, actually, the easiest way is to remember that if you do that, right, this angle is just double of that small one where this is 360 over 8, right? Yeah, so this is just 2 of those, which is 2 times 360 over 8.
Okay.
Right? 360 over 8 is how much? 90.
Yeah. No.
No, that's 4. Oh no, you can't do that. Yeah, it will be a decimal number. Right? So 2 of those, and once again, the next one would be just 3 of those angles. Right? So this one, that angle in the middle would be 1, 2, and 3.
Leave at 360 over 8.
Yeah, you should simplify it. Divide by 4. That would be 90 over 2, which is 45. Yeah, 45 degrees. Okay, that sounds about right. Yeah, so that one would be 45 degrees for each of these small angles. So the next one would be 90, and then the one after the triangle after that would be 135.
Okay.
Okay.
Yeah.
And for example, let's say this one here, this is 135, right? Then each of this would be 180 minus 135 divided by 2, which is going to be 45 divided by 2 is 22.5. This is 22.5.
Yeah. Okay.
Right? Because these are all radiuses, so they are all isosceles triangles.
Okay.
Right? That's about it. And then the last one would be calculate the angles. Using what you already know, can you find all the angles of this triangle? Okay. So I'll use that example. So the thing is this 2 point here, and then that random point here, right?
Okay. Yeah.
Now the easiest way to work it out is to break it down. How do we break it down? Join it to the center, like that. Right?
Okay.
Which means we can work out this angle, that angle, this angle, that angle, and this angle, that angle.
Okay.
Right? If you can work them out, then that's it. No, you can just find all the angles. So for example, see this one here, remember that was like 90 degree, right? So that would be 45, 45, and I think we did this one earlier, that's 22.5, this is 22.5. So that angle would just be 67.5.
Okay.
Does it make sense?
For 3 different triangles.
Yeah, just make 3 triangles and then work them out one by one.
Okay. Also, are you still screen recording?
Yeah.
Okay.
Yeah, I'm recording all of this.
Okay.
All right. Create some more triangles by joining 3 dots and work out the angle. Yeah, it's the same thing. All right. Just chop into 3 triangles that join at the center, and then you can work them out one by one. Optional. Center isn't inside the triangle. find it a little trickier to work out the angles. Draw one example. Center dot is inside your triangle. So yeah, I don't know what they mean by this. That's okay. That's optional extension. I don't think it will come out in the exam. Okay?
Yeah.
So the main idea behind this is to make up the 3 triangles using the center.
Okay.